Alright, ladies and gentlemen, so now let's see what we have here and examine whether equivalent ratios and proportions relate to real-world examples. So you are a sports medicine scientist and you're trying to measure how many times does the wheel turn whenever you pedal. Okay, and we can see that the ratio of a gear on a bicycle is 8:5, and that means for every 8 turns of the pedals, like that, 8 turns of the pedals, the wheel turns 5 times. So real quick, let's write that as a fraction with our ratio. Every time you turn the wheel, the pedal, right, pedal turns 8 times, you are going to turn the wheel 5 times. Okay, that's another way to write that. Now suppose the bicycle wheel turns about 2,455 times during the trip. So we're talking about wheel and that many times. How many times can you crank the pedals during the trip? So that's the one I don't know. So if I write this on the bottom, right, I need to make sure my units match up for my denominator and numerator. So if I have pedal turns on the numerator, right, I need to have the same pedal turns on the other ratio. Okay, and if I have wheel turns on the denominator, I need to make sure my equivalent ratio also has wheel turns on the bottom. Okay, so this has scaled up to 2,435 times for a wheel turn. So you would actually put that in the denominator because these have to match up. Right? So I don't know what the number of pedals are whenever the wheel turns 2,435 times. So if I don't know a number, you know in algebra, you always leave it as a variable. So there I set up my proportion. Right? And you gotta just make sure you know what is going where. And you define the pedals and then that for the wheel turns. Alright, so let's see what we got here. We have a proportion set up, and once again, we are going to use cross multiplication to find that variable p, like that, and then you are going to set up your proportion like this, okay? Multiply diagonally 8 times 2,435, and then 5 times p. Simplify that out, you're going to get 19,480 times 5p. And then to get p by itself, this is 5 times p, I have to undo the operation of multiplication by its inverse. So I'm going to divide both sides by 5, like that. Right? And then that 5 is going to cancel out right here, leaving me p all by itself. Right? And then this means you will need to crank the pedal 3,895 times, right, if you have this many times the wheel is turning. Right? So pretty cool, right? You can scale things from really small values to really big values. So now let's try these examples. You also can compare the ratios, right? So you can, if you look at this, right, 8/5, and then 3,896. 6, right? If I divide both sides by 1.6, top and bottom, you can get the same fraction here. So that's another way to look at that, to check your answer. And try these problems, okay? So just make sure, right, the units on the denominator, okay, units and denominator, and numerator must match. That's important when you're setting up these problems. Match. Okay, go for it.